Thank you. So the question is, what happens when you squeeze it? And generally, the answer is fairly simple. It's large, you put pressure, it gets smaller. We can all get on board with this. But sometimes when you go to very, very high pressures, the answer can be less than simple. So in this presentation, I'll show you how we can get to these high pressures and what will happen. To do high pressure experiments, we use a device called a diamond Anvil cell, as featured here. And generally, these are devices that can be found in the laboratory and go to the hundreds of thousands to millions of times the pressure that you experience here in this room on your body right now. Now, that may sound just like a crazy number, but as far as metals are concerned, we can see subtle changes in their atomic arrangement as we take them into pressure. But what's really cool about the diamonds is that not only can we go to these very high pressures because they're hard materials, but they're also transparent. So I can look and see what is going on with these metals or this liquid. Is it making a crystal? Is it changing colors? And it's terribly fascinating to be able to see what is going on in situ while we're doing these experiments. In addition to playing with diamonds, we also have this nice laser system here that takes us not only from our pressure, but also up into temperature. In geoscience, it's very common to want to simulate the conditions at the interior of the Earth. So we have pressure and temperature. Millions of atmospheres, thousands of degrees Celsius, and you can make a lot of cool things. What I've been working on is a substance called molybdenum dioxide. And generally, so before last year, this was the only structure that we knew that this substance took on. And it's some octahedra that are just slightly rotated in a little zigzag chain. Now it's interesting, it's nice, very good. We squeeze it, and everything rotates. Everything comes into these nice straight, long chains. Packing is very efficient. And yeah, that's exciting. We have a new material. This has not been talked about. Nobody knows about this. And we've just changed our understanding of this material. Well, we want to do more. We want to go higher. We want to go further. And what we've done is, using genetic algorithms, we've predicted this structure here. And you can see, this is very high packing efficiency, higher packing efficiency, weird conglomerates of things all kind of wrapped around. And that's not what I expect. You squeeze it, it gets smaller. This didn't happen with this. Now, I haven't found it. It may not exist. But I'm going to go look for it, because that's what we're doing with diamond Anvil cells and materials under extreme conditions. We're pushing the limit on materials' properties and our understanding of the physical nature of these chemicals. So I'd like to thank you for the time to present this today, and hope that you'll start pushing the limits in your own understanding of chemistry, of physics, and the world that surrounds you. Thank you.